Hello students, welcome back to the programming reference point. Today we are going to continue Boolean Logic chapter. In today's topic we are going to talk about NOR gate, NAND gate, XOR gate and XNOR gate. Before I start, I request you please don't forget to like, share and subscribe to my channel, and to get the notification of the upcoming videos, please press the bell icon. So let's start. NOR gate. NOR gate means what? When along with the NOR gate, if we add a NOT gate, it becomes what? The NOR gate. Okay. Let's see the definition. The NOR gate has two or more input signals but only one output signal. If all inputs are 0, then output signal is 1. It is just the complement of the OR gate. If we see the OR gate, 0 plus 0, it will give you 0. But the complement of 0, it is what? It is 1. 0 plus 1, normally in the OR gate, it will give you 1. The complement of 1 is 0. 1 plus 0, it is 1. The complement of 1 is 0. 1 plus 1, it is 1. And the complement of 1 is 0. So this is what x plus y not. Just the complement of x, y. We can draw the NOR gate in this way or in this way also. As we have seen the NOR gate, it is made up of the combination of OR gate and NOT gate. Similarly, we are having also over here the AND gate. The NAND gate. The NAND gate is formed when the NOT gate is added with the AND gate. It forms what? The NAND gate. So let's see the definition of the NAND gate. The NAND gate has two or more input signals but only one output signal. If all the inputs are 1, then the output produced is low, that is what? 0. So let's see xy. If you multiply 0 with 0, you will get the 0 as the answer. The complement of 0 is 1. 0 and 1, the answer is 0. The complement of 0 is 1. Again 1 into 0, answer will be 0. The complement of 0 is 1. 1 into 1, it is 1. The complement of 1 is 0. So this is, you can see it is what? The complement of xy. Okay, so this is what the output of the NAND gate. The NAND gate can be drawn like this or it can be drawn like this also. Now let's see the XOR gate. It is also known as the exclusive OR gate. XOR gate produces output 1 for only those input combinations that have odd number of 1s. So let's see this truth table. X, Y, here is the possible combinations. Now over here, where the input combinations are odd in number, where the number of 1, it is present in odd, so there only the output will be 1. If the combination of 1, it is even, let's say over here 0 and 0, that means no 1, that means the occurrence of 1 is 0, so here the output will also be 0. If we see here, the 1 is occurring for 2 times, so over here the occurrence of 1 is even in number, so that is why the output will be 0 over here. This is what the logic, this is what the circuit diagram of the XOR gate. Now let us see the possible combination which are summarized over here. 0 plus 0, it is always 0. 0 plus 1, it is 1. 1 XOR gate 0 is 1, and 1 XOR gate 1 is 0. Okay. Now let us see the XNOR gate. We have already seen the XOR gate, which is the exclusive gate. If we add a NOT gate with that gate, it will become what? The XNOR gate. XNOR gate produces 1 for only those input combinations that have even number of 1s. Okay, so here you can see where we have the 1 in the even combination, then only we will get the output as 1. Otherwise, we will get the output as 0. Let us compare with the previous one. You can say it is the complement of the XOR gate. It is just the complement of the XOR gate. Here we will get the 1 where the input combination has odd number of 1s, and here we will get 1 where the input combination has even number of 1s. Okay, just a minute. Should be 1. Even number of 1s. Okay, so let's see the diagram. if you see, compare the diagram also, here the NOT gate is not added in the XOR gate, but if you add the NOT gate, it will become what? The exclusive NOR gate. That's all for this video. In the next video, we will talk about the universal gates. So students, if you have any doubt, you can write down into the comment box, and please don't forget to like, share and subscribe to my channel, and to get the notification of the upcoming videos, please press the bell icon. Stay tuned, keep on watching the programming reference point. Thank you students for your patience.